So we talked yesterday about how to find sample space. And again, sample space, we're going to write this right here. Sample space is the set of all possible outcomes of one or more events in an experiment. So one way you can find a sample space of an experiment is using a tree diagram or a table. So for example, if you're going to wear either a red shirt or a blue shirt, and you're going to either wear denim, black, or khaki shorts, find the sample space using a tree diagram and using a table. I'm going to start with a tree diagram. To me, that's just easier. So a tree diagram, I can start with either a red shirt or a blue shirt. And from that red shirt, I have three options. I have denim, black, or khaki shorts, and I'm going to abbreviate. And then with blue shirt, I have denim, black, or khaki shorts. Okay, I can do that same information in a table. So I can do all this, or I can use something called the fundamental counting principle to find how many things are in this ample space. So that's the fundamental counting principle. So what the fundamental counting principle is it's for a compound event. Okay, you have to have two things to figure out the combinations. And so let's say we have our first event called M, and event M has M outcomes. Okay, event N has N outcomes. So what that means is the total number of outcomes of event M followed by event N is M times N. What that means, however many choices there are in the first thing times this, however many choices are in the second thing. So looking at this first thing, this first problem we had up here, there were 2 choices here for the shirt and 3 choices for the shorts. So 2 times 3 is 6. So there were 6 choices, 6 different combinations we could make. So this could be used for more than 2 events. If you roll a 10-sided die and flip a coin, what are the total number of possible outcomes? Well, let's think about this. For the first thing, I have rolling 10-sided dice. How many things are there? There are 10 combinations, or 10 different choices I could get. A 1, 2, 3, 4, so forth. Flipping a coin, how many options are there? 2, heads and tails. So I'm going to say 10 times 2 is 20. So there's 20 possible outcomes. So I can figure that out without having to make a list or a tree diagram of all of that. All right, look at number 7. Miss Greer is randomly selecting a boy and a girl to present at the assembly. If there are 14 boys and 17 girls in the class, how many possible outcomes are there? So first, you're going to choose a boy, and then girls. So if there's 14 boys and 17 girls, I'm going to multiply 14 times 17 to figure out the total possible outcomes. And if I do that, I'm going to get 238. So there's 238 different combinations I could make using those 14 boys and 17 girls if I picked one boy and one girl. All right, let's look at some more examples. Okay, we're going to go ahead and look at this first problem. The new pizzeria lets you choose your crust, your sauce, and 1 topping. Find the total number of all possible outcomes. So I know I'm going to choose 3 things. There's 3 events happening. Your crust, your sauce, and your toppings. So how many choices are there for my crust? 3 choices. What about for the sauce? 4 choices. What about for my toppings? 7. So what that means is I'm going to go ahead and do 3 times 4 times 7 to figure out how many possible outcomes there are. 3 times 4 is 12. 12 times 7 is 84. So there's 84 different combinations. Okay, you have shirts that are red, pink, and orange. You have pants that are blue, black, white, and gray. Find the total number of possible outcomes. So I have shirts and I have pants. How many shirts do I have? 3. And how many pants? 4. So I'm just going to multiply that and I'm going to get 12. So there's 12 different outcomes that I could get if I choose one of those shirts and one of those pairs of pants. Okay, you spin or you roll a 6-sided number cube and then spin the spinner below. What are the total number of possible outcomes? Well, first you've got the number cube. Okay, and how many choices are in the number cube? 6. There's 6 sides. So I have 6 on the number cube. And how many choices are on the spinner? 9. So that means I'm going to say 6 times 9 is 54. So there's 54 possible outcomes. So every student gets to play a sport and make a craft at field day. The sports options are volleyball, basketball, lacrosse, flag football, and relay races. The craft choices are painting, pottery, and sand art. Find the total number of possible outcomes for the students. So I know I have sports and I have crafts. So how many options are there for sports? 5. And how many options are there for craft? 3. So 5 times 3 is 15. So there's 15 different outcomes. For this next one, I want you to create a compound event that has exactly 15 possible outcomes. So as you're doing this, you know that it has to multiply to get to 15. Now 15, the only way you could do that is to either have something multiplied 1 times 15 or 3 times 5 or 5 times 3. So just think about that, and I want you to come up with your own scenario.